Okay, let's go to that. All right, so I gave them the sheet. The sheet is on, I believe I put on the calendar. I better check that. Hi, let me just do that right now. You know, my ADD kicking in. Sometimes I forget to do things, so many things to do during a day for teachers. So Wednesday's blank. So I do have to find that. All right, let me just take care of that now. What a stunning start to this video. Let's watch Mr. Samuel adjust his calendars. Okay, so what chapter is this? Chapter 8, right? All right. So this is fun. Perhaps I'll get rid of this one. Nope, it's not that one. It's that one. Boom! I know it's. Oh, come on, get the whole thing. There we go. Copy, paste. Well, now you key copying bums. I'll put the key there. Good luck if you copy that key and turn it in tomorrow for 3 measly, stupid homework points, which causes you to get an F on a 100-point test category situation. Still understand how that's still happening. All right. And I just had it last hour. Saw a bum. Hey, this is what you should do. Divide by R squared. Just so you want to fumble, just so you understand the comparison to an ellipse. All right, so they could really get this figured out, those that did not and didn't do so well on that quiz, which I do have to give that back to you to kind of look at. Because really, the quiz that you took, when we take the test next Tuesday, and it is going to be Tuesday, there really isn't going to be that much of a difference except adding hyperbolas. And it really, the format's going to be very, very similar. So hopefully we learn from that. But anyway, circles, you have the same radius, right, left, up and down. Look at what this worksheet even did. They called the center the actual focus. You know, it's kind of weird. It's the focal point where it's equidistant to just that one point. Where for ellipses, it's the focuses or foci that actually make the ellipse happen. Remember my drawings over here? The farther the foci were away from each other and the more tethered the string, the more ovular the situation was. That was an eccentricity that was closer to 1. All right, so here's some things you should mark down for sure. Absolutely. 100% for ellipses. C, I know they have A is greater than B, but I'm going to add to this. C is most certainly smaller than A. That's why we have to have that subtraction. And then remember, I told you the ridiculousness. If you choose the wrong formula, then C is on the outside of A. That's like saying Earth, here's the sun, and here's Earth's orbit around the sun. Does that make any sense? The sun is outside of the Earth's orbit? Yes or no? No. Right? And that's the whole point that I made when I did the drawings up there, and some people said that was helpful. All right, so anyway, choosing the right formula because now we know we have hyperbolas, which it's a different formula for that. All right, and then yes, A is bigger than B. It's just saying that we go wider instead of tall and shorter, right? So yes, A is bigger than B because of how the radii work. And I really don't have anything else to say. They do say major and minor axis, good. They do say horizontal major axis. That just means it's wider. This just means it's taller and skinnier, where the bigger number is underneath there. Right, so it's really not a big deal. And I am going to highlight this again. C is along the major axis, so it does go up and down in this case. All right, that's where the foci are there. So I want to highlight that thing and then really hammer down the point that C is smaller than A again. Okay, so I think that's all we could really say. Just get used to these terms here, vertex and covertex. Even this worksheet uses this, even though our book doesn't. Our book didn't call those covertices. They call them endpoints of the minor axis. Okay, and then I think it's smart to keep going with these, which are similar in equation. Hyperbolas, let's color that in green. Let's color that minus sign in green. That's what makes a hyperbolic equation there. You're going to be infinitely sad when we go to the test. I'm going to tell you right now, you're going to have to graph by hand a parabola, a hyperbola, and an ellipse. And for a hyperbola equation, you draw an ellipse, you're gone. That's going to be major points off, and vice versa. If you have an ellipse equation, then you're gone. And then I guess this is what I could do for an ellipse. Color in green that it's plus there, and it's plus there. not minus. Right? So we got to make those indications there and understand the difference. Get our files organized. Okay, and then for sure, yellow. That is the most important. And then for sure, this doesn't have this, but C has to be greater than A. That's why it's plus. Because, let's go to the graph, C has to be bigger than A so that it could be in the bowl, right? We at least have serial bowl for this. So C makes B bigger than A, makes the focus inside that bowl. Right, so drawing that with highlighting and the action of doing that and then seeing this later really makes you not pick the wrong formula. You pick the right one. You don't flip a coin between plus or minus between these two. Oh, and then there's one more thing you should write here. Good axis. Good is positive, bad is negative. Good axis is the x-axis. That's why it goes right, left. That's why this goes right, left. You can see the hyperbola actually drawn right, left, not up, down. And then destroy this. Get rid of this. If you have a black highlighter, color that in black or something. But this, I don't want you to be doing slope B over A or A over B. No. There is no A's and B's on this, but there is, I guess. That's just called the transverse axis. Notice that term up there, horizontal transverse axis. Transverse is good axis. Conjugate is bad. All right, so cross that off. I'm going to write something on the bottom for that. Let's mark this up, though. Good axis, y-axis. Good axis is the y-axis. And then let's look at this thing here. C, again, is bigger than A. But, of course, in this case, C goes up and down because the hyperbola goes up and down. And it goes in both cases there, but I like how they mark it just in one thing. Destroy this. Notice that says now A over B. And then that's a coin flipper. Which one is it? B over A over B? What's the slope? Wrong. This is what we're going to do. Oh, and by the way, I should highlight this in green. Minus again. All right. Good axis, bad axis. That makes it a hyperbola. So if you highlight that in the same color, when you look at this later, oh, green, green, green. Oh, the minus sign makes this a hyperbola. Ellipses, green plus plus. Oh, a plus in between makes that an ellipse instead of a hyperbola. But now let's do the asymptotes here. What's the two R's? Grade school. What's slope? R over R. 3, 2, 1, go. Rise over run. So if we simplify it to that, and we look at each of these boxes, the rise over run is always y axis over x-axis maneuver, or y-axis radius over x-axis radius. So that's what I'm going to put here. This translates to y-axis radius, whatever that is, over x-axis radius. And that makes it a lot simpler. So I'm going to write the equation of a line here and then mark it up with some more highlighting, but I'm running out of highlights. So if you have another different fourth color, grab it. I'm out. I do have another one, but it's too dark. So what I'm going to do here is in yellow, you pick a different color, highlight all this, and then understand that goes right there, whatever that is, right? That's the slope. Now that's a point slope equation of a line. I didn't want to write that again. We did do this back in chapter P, and this is a Math 1 concept. But then another thing I want to write here is not highlighter. I want to write the word center. And then I just want you to know that these asymptotes cross the center at these points. So that's what goes in those two positions, the center. Oh, one more thing. This is plus minus. There are two asymptotes, one with a positive slope and one with a negative. So you want to write the plus minus number there. And then your job was just to leave it like that. I told you that worksheet generator I used yesterday, they solve them both. for y, you don't have to do that. Okay? All right. Now we're almost done. And I did do a little stuff in the beginning, so we went over some questions. Do not confuse parabolas with hyperbolas. This happens all the time. This is not good axis, bad axis. This is what I get people doing. Oh, the good axis is squared, x squared, so it goes right, left, because that's wrong. What we did for this was for every y, there's two x's. So for every y, there's two x's. And I'm using that focal width thing there. You know, that other 2 points that you should draw. And I'm going to ask you to do that on the graph. You got to get those two other specific points. I don't think I said it too much on the quiz last time, and I didn't account for it. I will on the test Tuesday. Okay, so for every y, there's two x's. So when x squared goes up or down. All right, we have something else we have to change. You see how it says p there? These should say p, so not cp. I think I changed that p. It was c, and I changed it to a p. I didn't want to confuse you. So these should be p's. And that's the point. Whatever p is in that 4p situation, for this one we go p up for the focus, and then we p down and have a, okay, we should write this as well. Both of these are y equals a number, not x equals a number. Y equals a number here and here. All right, so make sure you know horizontal lines are y equals a number. These are my pet peeves that will be marked wrong so quick your head will be spinning if you don't do these right. Okay, and then we got to change these to p's. P, P, P. P is the key, like I had with Mr. High, giving him a mention on YouTube. Love that guy. All right, and then for every x, there's two y's. That makes this go right, left. Here's an x coordinate. There's two different y coordinates. By the way, that's called the focal width right there, right? So this is 4p long. So that's how we got those last 2 points there. So I guess I could put that right there in one of these. This is the focal width. That equals 4p. That is called the focal width. And I do use that just to make the picture a little bit better. Get me 2 more coordinates. So don't forget about that. That's in all 4 of those drawings. Yet again, we got to change these C's to P's. I think I recall that now. I manipulated this. I stole it off the internet, but then I made it into R letters. Not a big deal. That teacher would say C is the key, and they put 4C in front of that. I think I could see that I put a P in front of this. It's a little different font. I think I remember doing that. All right. And then is there anything else to say about this? I guess I could have put cereal bowl table. Remember, that's what we do with this. Cereal bowl table. That's the only one that works for. Right? That tells me where everything goes. All right? And that's how we deal. That's our parabola file. And you got to really lock these down, man. Your files in your brain got to be like this. Like these have to be rigid blocks in your brain that keeps these all separated. But I would argue that these 3, 1, 2, 3, have a lot of similarities. All right, a lot of radius moves that are correct, but then we just have different things for each one. And that's how you got to organize your brain. Your brain has got to be blocked off into these 4 files. All right, and then you go from there and assess what you have here. Oh, let's see what I have here. I think I have all the, I don't want that. Let's see if I have this one. Oh, let's go to this one. Oh, darn, that's a different one. Okay, never mind. All right, I'm going to stop the movie at this point, I think, if I know how. Okay, so here's what